Share my screen. Okay, and Osni, if you can't see what I'm talking about, please let me know. Thanks everyone for joining. As Osni said, my name's Greg Watson. I work at Oak Ridge National Lab and have been involved with Eclipse for quite a few years. And I was asked to give a webinar on the use of Eclipse as an integrated development environment for developing scientific and high-performance computing software. So what I want to try and do today is take you through some of the basic process of getting hold of Eclipse and installing it. And then I want to skim over some of the features that are available for doing C and C++ development and Fortran development, which are the predominant languages for high-performance computing. I realize that Python is used very widely, and there is Python available for Eclipse, but I'm not going to be covering that in this webinar. And then I want to look at a couple of kind of real-world scenarios where you would be using Eclipse to develop an application for a high-performance computing system of some kind. And we're going to use a real application that's available on GitHub as a demonstration for that. And I'll talk through some of the mechanisms for doing that development. And then finally, and hopefully we'll have a little bit of time left, we will look at some of the features that are available for utilizing the facilities of HPC systems. So things like job schedulers and system monitoring and things like that. So that's what I want to cover today. Now, I noticed that there's already been some questions in the Google Doc regarding debugging, and I'm not going to cover debugging today, but if you would like to make a list of topics that you're interested in seeing, we could look at maybe running another webinar in the future that would cover those topics. And obviously debugging is an important area. There is significant debugging support in Eclipse. It's just that would probably be a whole webinar in its own right in order to cover that. So we don't really have time to do that today. Okay, so I know from the questions I've seen, I know that there are clearly some people that are using Eclipse already, so you know what it is. In the interest of people that don't know what Eclipse is or haven't heard of it before, I just wanted to briefly cover what it is. And essentially, it's an integrated development environment, which I think is a bit of a misnomer because you could arguably say that, the Linux shell is an integrated development environment because it integrates a whole bunch of development tools together. So really, Eclipse is a graphical user interface for a development environment. So it integrates a lot of tools in a graphical manner rather than through the command line. It's also a platform for developing new tools and applications. So you can write tools, develop tools, and in addition to that, applications themselves, and deploy them in Eclipse. And there is a comprehensive way of installing new features and new functionality into Eclipse that we'll touch on briefly. And the final aspect of what Eclipse is that it's an ecosystem for collaborative software development. So there are thousands of developers involved in developing Eclipse. It doesn't all have to be Eclipse-specific software. In the science working group and the science top-level project, we have projects that are not Eclipse-based, but they utilize the Eclipse ecosystem and take advantage of that. So if you're interested in getting involved in anything, or you have software that you might think might be interested, you might be interested in hosting at Eclipse or becoming involved in the science working group, please reach out to me. Okay, so getting started now, what I want to cover is just how you get Eclipse and install it. And I'm going to cover this pretty quickly. So essentially, Eclipse comes in a variety of different packages, and you can really use any package as a starting point. But in order to get the functionality that I'm going to be talking about today, you may need to install additional components. So there are a couple of packages that are really best for scientific computing, and there's the package that is part of the Parallel Tools platform project, which is called this Eclipse for Parallel Application Developers. That would be the one that I recommend. And then there's another one called the Eclipse IDE for C and C++ developers. So if you're just interested in C and C++ development, then that's a kind of a lightweight package that just has that functionality in it. So the main download site is eclipse.org/downloads, and I'm just going to quickly switch to that. So if you go to that site, you would see something like this, which has a bunch of stuff that doesn't look like it's very interesting at all, but there's a link here, download packages, under Get Eclipse Oxygen. If you click on that, it takes you to a list of all these packages, and these are the packages that I was talking about. And the Eclipse IDE for C++ developers is here, and then if you scroll down further, you'll see Eclipse for Parallel Application Developers. And you'll notice downloads at the moment is 0, and that's because we just released a new version of Eclipse today. Today was when that release came out, so I'm not exactly sure when these are updated, but I downloaded it today, so it should actually read more than 0. But anyway, so that's what you should see, and that's where you download it from. I'm not going to download it now because it takes a while, obviously. But when you download that, let me switch back to here. Let me just briefly cover these two different packages, and then I'll take you through the installation process. So the Eclipse IDE for C and C++ developers, that contains a range of tools specifically for C and C++ development. So things like editors that understand the language, build support, tool chain support, and various other things. It also includes integration with Git, and that's very closely integrated into Eclipse these days, so it has quite exemplary support for Git. Other revision control systems are also supported, but you would need to install them separately. And then there's a bunch of features to support different Linux tools, so things like gcov and valgrind and trace compass and so forth. So they're also integrated into that particular package. The next package is the Parallel Application Developers. So essentially, this package contains everything that the previous package contains, plus it contains some additional functionality that I'll be talking about a little bit today. So this functionality of synchronized projects. It contains Fortran support if you're interested in that. And then a number of features for interacting with remote systems, so job scheduling, monitoring, and a remote console. So that's why I would recommend that one for scientific application development. Okay, so in installation. So Eclipse requires Java to be installed on your machine, that is your laptop or your workstation. So the first thing you really need to do is check if you have Java installed, and you usually do that by bringing up a command prompt and typing a command like java-version. And that will obviously, if Java isn't installed at all, you'll get an error. Otherwise, it should tell you the version of Java. And you'll need to make sure that you have at least Java 1.8 installed. Previous versions of Eclipse have used earlier versions of Java, but the current version requires at least 1.8. If you don't have Java installed or you don't have the right version, then you'll need to follow the procedure, whatever that is for your particular operating system, I'm not going to go into that today because each operating system has its own procedure for installing Java. So there's a lot of documentation online. If you just Google for that, you can find out how to do it. So once you've got Java installed and functioning, then you're pretty much good to go with Eclipse. So you download the Eclipse package from that website I showed you previously. And then depending on your operating system, you get a different type of package. So you'll get a zip file for Windows, you'll get a tar.gz file for Linux, and you'll get a DMG archive for Mac OS. So essentially what you do is just uncompress that archive, based on your operating system, and then just move it to wherever you want to put the Eclipse installation, and then you launch it. So I'm just going to quickly take you through that, show you what it would look like. So this is Mac OS, and it'll be obviously a little bit different for other operating systems. But here I've got the parallel pack, the Eclipse parallel application developers package for Mac OS. It's a DMG. So I'm just going to double click on that. Mac OS mounts that as essentially a drive, and then you can just take the Eclipse application and drag it to wherever you want to install it. So I'm just installing it in essentially the same location that I downloaded that package, and that's it. Eclipse is now installed. You can put that anywhere you want, and so then you launch the application by double-clicking on it, or you may do it from the command line for Windows or Linux. And so when Eclipse first starts up, it asks for a workspace, and so this would be where any projects that you create are going to be located. You can have multiple workspaces, so it doesn't really matter where this is located. So you can essentially choose wherever you want. I'm going to choose just this webinar directory, and then I'm going to call it workspace. And you'll see it appear, so the workspace just appeared there. And now Eclipse starts. And so if I create projects, I'll go into that directory. If I want to create a new workspace, then I can do that and have projects in a separate location. So when Eclipse starts up for the first time, it gives you this help screen, and you can just click on these different links, and it will take you to some documentation if you're interested in that. Otherwise, you can just uncheck this box down the bottom right-hand corner, and then click on the workbench icon, and that will take you to the workbench. So Eclipse is now installed and ready to go, and it's that easy these days. It used to be a bit more complicated, but now it's quite straightforward. So before we get into looking at some of the features, I just briefly wanted to mention how you can add features to Eclipse, and there's now two mechanisms for doing that. The best way to add new features is to use the Eclipse Marketplace, and essentially this is a place where anybody can publish Eclipse software and make it available. And it's not just free software as well. There's also commercial software on here. There's over 1,600 packages available currently, and they've had 20-something million downloads. So it's quite a big marketplace. It's got a nice functionality to be able to search through the packages and find functionality that you're interested in. And for example, if you wanted to install Python, I would recommend going to here and typing in to the search box PyDev, P-Y-D-E-V, and that will bring up the Python development environment, and then you can install it. You get to the marketplace from the IDE by going to the Help menu and then going down to the Eclipse Marketplace menu and choosing that. So that's available through Help. There's another way of installing features which is from what are called Eclipse update sites. And essentially these are repositories that anybody makes available. Typically a project will make an update site available for their project only, and they'll put new versions of their software available on that update site. So they're good for updating installed software to the latest version, or if someone gives you the URL to the update site, then you can just plug it into this the dialog, and it will show you what's available at that site, and then you can install it. If you don't know the URL, then it's not as easy to use as the Eclipse Marketplace. And that's also accessible from the Help menu. So you go to Help and then Install New Software, and then you can type in the URL if you know it. So they're the two main ways of adding functionality to Eclipse, and I just wanted to point those out to you. So now I'm going to switch to talking a little bit about how you can use Eclipse for developing C, C++, and Fortran applications. So I might just briefly pause here and ask if there's are there any questions at this point? Or any concerns?
So there was one question inside of the Google Docs in relation to, I think, something you were just saying regarding, the question is, uninstalling old version or upgrade? And I'm not 100% sure which part of that was applicable to what you were saying. And maybe the person that can ask that could clarify. Oh, they're clarifying.
So is the question, how do you uninstall an old version? Essentially, you don't really need to uninstall Eclipse. If I downloaded a new version of Eclipse, an Eclipse package, I could just install it exactly the same way. In fact, I could install it alongside this one and have two copies of the Eclipse application side by side. You obviously have to call it a different name, but you can run different versions simultaneously. If you point them both at the same workspace, you'll only be able to have one opening that workspace at a time. So you can't have two versions of Eclipse opening the same workspace simultaneously. And also, later versions of Eclipse typically upgrade the workspace. So if, for example, you had Eclipse Oxygen, which is the current version, and you're working on the workspace, and you downloaded the next version of Eclipse, which is called Eclipse Photon, it will probably upgrade the workspace so that you can't open it with an older version. So that's a consideration. But you can always just copy the workspace. It's essentially just a regular directory. So I could just copy this and clone it, and then have two copies of that workspace, one that I was working on, Eclipse Oxygen, and one I was working on, Eclipse Photon. So there's a lot of flexibility in terms of how you do that. The Eclipse update sites allow you to update a particular version of Eclipse. So for example, again, if this is Eclipse Oxygen, if they bring out a version of Eclipse Photon, then I could go to the Help menu and say check for updates, and it should find a new version, and that will update this version of Eclipse that I've got installed here to the latest version of the software. So, you know, there's many ways to do it, but typically you don't really need to uninstall. If you do want to get rid of this application, you essentially just drag this to the trash. It's pretty much self-contained, and that will uninstall that version. So hopefully that answers that question. Okay, now I want to talk about developing C and C++ programs with using Eclipse, and I'm going to start talking about C and C++, and then we'll move to Fortran a bit later on, and I'm going to try and demo some of this for you as well. So I'm going to be switching backwards and forwards between the slides and that version of Eclipse I just installed, just so you can see some of the features in real time. So for C and C++ development, it essentially works best on local projects, and by here I mean a project that is on your workstation or your laptop. And I'll address how you can work on remote systems later, but if you're just using the vanilla C and C++ development environment, it works best locally. And it also assumes a hierarchical directory structure for the project. And that's just something that's built into Eclipse. You can have multiple hierarchical directory structures, separate projects that have hierarchical directory structures. But if you have a project that has a very weird directory structure, it may not map directly into the Eclipse resource structure, and you might need to create another level of hierarchy above it in order to get it to map into the Eclipse hierarchy. So that's probably the most difficult thing that you might encounter. These days, most projects are pretty hierarchical, particularly if you're using something like GitHub, because it kind of mandates that you have to have a hierarchical structure to your Git repository. So you don't typically run into that behavior, but it's just something to be aware of. The C and C++ tools support makefiles, and there's new support for CMake that's in the latest version. So that's pretty well supported now. You can work directly with Git repositories, and I'm going to show you that in a minute. And also you can manage multiple Git repositories from one Eclipse workspace. So that's pretty cool if you're working. I mean, like I work with maybe 40 different Git repositories, so that I can do all that from one Eclipse workspace. So essentially, what we're going to do is we're going to clone the Git repo onto our workstation, and that will be our workstation repository, and then we're going to import that into Eclipse. So that's the typical scenario for working locally. So the way we do this is we go to this import menu, and we use an import wizard to do that, and then we specify the URI to clone, I'm going to show you using this NYX application that I found in GitHub, which I think has a nice combination of C and C++ and Fortran in it, so you can see some real code and how that might be imported. And then once you've cloned this, you import it into Eclipse, and I'll take you through the steps of that. So I've documented it in the slides here, and I'll just show you now how we do that. So the first thing I'm going to do is just copy this link, because I'm going to need that in a minute. And I'm going to bring up the version of Eclipse that I started before, and so I'm going to follow what the slides say. So I'm going to go to the File menu in Eclipse, and then I'm going to say Import. And then you'll notice there's a whole bunch of things here that you can use to import things with. And I'm not going to cover all of those, but the one we're interested in is in this Git folder. So I open that up by clicking on that triangle, and I'm going to say Import Projects from Git. And if I already had cloned it, I could just use existing local repository, but in this case, I'm going to specify the URI that I'm going to clone it from. And you'll notice it actually pre-filled it in for me, because I had it in my copy buffer. So it actually filled it in automatically for me. And you can see that it's filled in the various pieces here. And also, because I've used Eclipse previously to clone repositories from GitHub, it also has my credentials stored in a secure store. You can choose not to use the secure store, in which case you'll have to enter your credentials every time. But the Mac has a keychain, and it stuffs it in the keychain, so it'll automatically pull it out. So I'm just going to say next. So this now goes to the repository and it finds all the branches. So you can pick which branches you might want to import. I'm just going to pick them all. And then you can specify where to put the repo. And again, I'm going to go to my webinar, and I'm going to put it in here, and I'm actually going to say, yeah, I'll just put it there. So I'm going to, the Git repo will be in this webinar folder. And I can specify things like the initial branch and so forth, but I'm not going to mess with any of that stuff. And then I'll just click on next. So what I'm doing now, so now it's importing, and actually, I actually accidentally went one step too far. So I just wanted to, before I actually do the import, I want to show you that you have three options. Once the repository's been cloned, you can, if the repository actually contains Eclipse projects already, you can import those directly. You can also import, once the clone is finished, you can fire up this new project wizard, which will allow you to configure different types of projects. And then the final option, which is import as general project, is just going to import it directly into Eclipse as a project of no particular type. And we're actually going to use that one in this case. So I want to select that one, and I'm going to go back to, so now because I did this before, I'm going to now change this to so this is where we got to before. So so now it's cloning from the GitHub repository. So you can see this takes about 30 seconds, assuming my internet connection is not over encumbered by the webinar session. But so essentially, there's about 250 megabytes of source code for this particular application. So this is cloning it. So essentially, this would be identical to going onto the command line and typing git clone and then the GitHub URI. So essentially, it's just creating a directory on my machine that contains a clone of that repository. And when that's finished, you will see it's taking a bit longer than normal. But you see now the directory has been created here, which contains the Git repository.
So Greg, may I interrupt you for 1 second while we're
Yeah, now's a good time to ask questions. Yep, definitely.
Yeah. So we had one question in the Google chat doc, which I just copied into this chat, but they're asking if there is any support for cross-language development. In other words, compiled Python extensions written in C or C++.
Specifically for Python and C, I don't believe that the PyDev development environment has any specific support for that. But you can definitely create a Python project and a C project within the same workspace, and you could develop a Python module, you know, in the C part, and then you could reference that from the Python development part. So you could work with them together. I mean, I haven't actually done that, so I'm not sure what the configuration setup would be to do that, but I think it would be eminently possible. But there's just not, as far as I know, there's nothing specific in the development environments to deal with that case. So there was another question about how good is Ubuntu 16 or Linux support for parallel setup. It should work fine. I know there have been some issues with the GWT, the widget toolkit on Linux and Eclipse. I think that those issues have been resolved, and so as long as Eclipse, works well on the version of Linux that you're using, then you shouldn't have any problems. The parallel tool aspect of it should all work nicely. I've done quite a lot of testing of the parallel tools on Linux, and I haven't encountered any problems. There's a question on hybrid parallelization. So in the parallel application developer package, which I'm going to show you later on, we do have some support for MPI and OpenMP. It's really predominantly in the editor. So there's a lot of, there's templates and there's context-sensitive help and things like that available for MPI and OpenMP. There's not really, there actually are some tools that do static analysis of OpenMP and MPI programs, but I wouldn't say they're something that you could use in production. You might want to take a look at them and see if they're helpful to you. But other than that, the compiling of and performance optimization and that kind of thing, you're relying on tools outside of Eclipse to do that aspect of it. But if anyone is interested in developing new tools for working with MPI and OpenMP, then please let me know. Okay, so the clone is finished. I'm going to import this as a general project. I'm going to call it NYX and click on Finish. Okay, so now I've imported that project, and the next step before I show you more details about that project is to make it into, so at the moment Eclipse just thinks this is a bunch of files. It doesn't know anything about this particular project. So we're going to tell Eclipse that it's actually a C and C++ project, and that it contains C++ files. So in order to do that, we right-click on the project, and then we go to New, and then Convert to a C and C++ project. And all that does is it is going to tell Eclipse that this is a C++ project. You can also choose to tell Eclipse what type of project it is. And I don't really want to get into this other than using this makefile project. So essentially NYX builds with the makefiles. So we're just going to say it's a makefile project. And because it's on, I'm on a Mac, I'm going to say that if I was going to build it on here, and I'm not going to, but if I was, then I'd be using the Mac OS toolchain to do that. And then I just say Finish. And you'll notice down in the bottom here, there's a C++ indexer. So as soon as I told it that it was a C and C++ program, it starts running this indexer, which goes through and indexes all the C and C++ and header files and code file, source code. So that's run, and as I mentioned, this is 250 megabytes of source code, so it happened pretty quickly. Next, so the next thing I want to show you is the Project Explorer. So now that we've got this project in our workspace, I can show you some of the features of Eclipse for actually developing this code. So the main kind of interface for the source files is this thing called the Project Explorer, and it's like your File Explorer, except that it has some additional functionality specific to development. So if I click on this triangle, it's going to open up the project, and you can see that this project consists of a number of directories, which are indicated by these icons. There's a couple of source text files here. And there's also some virtual nodes. And Eclipse creates these automatically for you. So this virtual node here called includes is derived from the tool chain information that I specified, and it actually worked out where the include directories are on my machine, and it puts them into this virtual node. So if I open that up, you can see the directories of my the Xcode toolchain, which is the C++ compiler I'm using. So if you're on Linux, these would be your, whatever the Linux toolchain is. There are also some other virtual nodes that aren't shown here because I don't have any files in the source tree yet. But if I had binaries or libraries, then it would create a virtual node to collect all those together, so it's easy to find them. So rather than having to navigate down through multiple levels of directories, you can just open up a virtual node and it will show you the the binaries or executables that you've compiled. You can drill into the source code and you'll into the source directory, and you'll see the source code here, and you can see all the different file types. And you can actually continue to drill into files as well. So, for example, I can drill into a C++ file by clicking on the icon next to it, and it lists all the structural components of that file. So things like include, paths, classes, methods, enumerated types are all listed in this Project Explorer. And in fact, you can keep drilling down, so you can see I can also expand this class here, and so now I can see I can see the destructor here. I see some static fields and methods and so forth, and there's icons indicating whether they're private or public, and whether they're static and virtual and all that kind of stuff. So there's a lot of information that you can gain just through the Project Explorer. This Project Explorer provides a really good way of navigating around. Now, in addition to the Project Explorer, there's also over on the right-hand side here, which you can't really see. I'm just going to expand my screen a little bit. So this view here that says outline. So this provides similar information to the information that's displayed in the Project Explorer, but it does it for a particular file. So if I open a file by double-clicking on it, and that will open it up in the editor, you'll notice that the outline view is now populated with similar sort of information, but this is now specific to the file that's open in this editor. And in addition to that, I can use this information in the outline view to navigate around. So if I say I want to go to whatever this is here, this ppm type, I can just click on it and it will take me to that location in the editor. So it's very good for navigating around. Whereas if I click on what's over here in the Project Explorer, it's not navigating around, but I can open this up for any file. So that's those views. The editor. So let me talk now. There was one other thing I wanted to show you about the outline view. So you can, of course, expand. If there's compound types in here, you can expand those as well. You can also filter what's displayed in here, which you can't do easily in the Project Explorer. So, for example, if I want to display everything in sorted, alphabetically sorted, I can click on that. If I want to exclude static members, I can click on that. If I want to hide non-public members, I can click on that, and so forth. So you can filter what's displayed in this view as well. And in fact, if you click on this little down arrow, you can actually specify quite detailed filtering if you want to do that. So that's another set of features that the outline view provides. So the editor, and I'm going to, let me just expand this a bit more. I want to talk briefly about the editor and some of the features associated with that. So you can see that, like most editors these days, the Eclipse editor has syntax coloring. So keywords and, in this case, preprocessor directives and things like include files and so forth are all colored appropriately, so you can discern those. The colors are all completely configurable, of course. So that's pretty common. You'll notice that line numbers are enabled by default, so you can easily turn them off if you don't like line numbers, but they're enabled by default. This is also a folding editor, so if you find a structure, and I'm just scrolling down to try and find something to show you. So here's a method. So you'll notice that there's a minus in a little circle here. So this is an indication of a fold point. And if I mouse over that, there's a line is drawn in the editor indicating the extent. And if I click on, so if I click on that, it folds that that structure up into a single line. And in fact, you can, if you right-click on this part of the editor, you can expand or collapse everything. So I could say collapse everything, and so now my editor is completely folded. Or I could expand everything, and you can disable folding if you want. Here's how you can enable and disable line numbers. So if I don't want to see line numbers, I can just turn those off. If I want to expand everything, I can just go back to that. There's hover help. So essentially, if you hover over something that it knows about, so for example, here I've just hovered over this variable done. You can see that the hover help pops up and it shows you the type declaration for that. And of course, that will work regardless of where that type declaration is. So if it was in a different file, then you would still see the in this code, I've got some
Hey, Greg.
Yeah. Yep.
So you're really breaking up. We're having some audio problems. I'm just going to pause for just a second. Maybe it's your internet connection. Can you just do some testing real quick?
Sure. How is it any better now?
Yes, very good.
Okay.
You may need to repeat about the last 20 seconds.
Apologies about that. Maybe it was my microphone. So let's see. I was talking about hover help. Essentially, if you hover over a variable or type, or in fact anything that has some sort of semantic information associated with it, then Eclipse will pop up some hover help, and this can be declared in a different file. And because it's indexed the whole source tree, then that information will be available. Another feature of the editor is known as code activation. So here we have two macros that in this case are not defined. So gravity and forcing are macros that don't have any value at the moment. And so Eclipse shows them as being grayed out. So it shows you that this piece of code is not active. If these macros had values, then depending on what the value was, then well, this is an if-def, so it just needs to be defined. Then this would be showed as normal white background. So that works for any. So here's an example of an if-def else. So because this macro is not defined, then this is inactive, this part of the code, and this part of the code is active. So you can see exactly what is enabled very easily in the editor. There is a very sophisticated formatting framework and you can reformat the entire source code tree if you want, or you can do it on a per file basis, or you can do it on a region of code. So you can just select a region of code and then go to source and then format, and it would reformat that code based on whatever rules that you've set for the formatting. The final thing I wanted to show you is the integration, some of the integration with Git, and in particular, you can annotate. So if you're working a lot with Git repositories, you can annotate the editor with revision information. So I can say show revision information here, and now it actually puts the commit information in the editor. And so this is showing me that this piece of code here was committed by Anne Almgren on this date, and it was the initial version. And you know, you can see other commits and so forth. And it actually even shows you a diff of the commit that was made. So you've got, you know, a really good way of tracking what's going on in the source code. And then this is quite configurable as well, because you can go in and you can configure the revisions by author, or you can show additional information like the author and ID, and etc. So there's quite powerful integration, and that's just in the editor. There's much more integration with Git than just this. Okay, so the last thing I want to talk about with the C and C++ side of things is formatting and refactoring. So I mentioned that you can just reformat. You can just reformat a piece of code, but in this source menu, you've also got some tools for doing quite common activities. For example, like organizing your include file, so that will remove any unused includes, or it will sort them, or whatever. You can pick the rules that you want for organizing include files. You could, for example, take a piece of code and automatically generate getters and setters for it. You can take a piece of code and, well, actually this will just implement a method, so you can just type in the method parameters and it will write that code for you. And you can do indentation and things like that. So there's quite powerful source manipulation tools. And then there's a whole refactoring framework which is available through this refactor menu. And there are a number of different refactorings that you can do. So for example, say I had a piece of code like this one here, and I wanted to make this into a function or a method. I can just say extract function, and I can give it a name, and it will Eclipse will automatically detect what the parameters are that you would need to define a function that calls these different methods, and you can choose the access modifier and so forth. Here's the function signature that it's going to create, and then if you click on the preview button, it will actually show you that it's going to add this to the class. So it's going to add a private method in the header file, and then if you click on the source file, it shows you the method that's added into the source file. So here's the declaration of the method, the parameter that you pass through, and then the body of the function, or the body of the method. So there's a lot of functionality like that, which makes it quite easy to manipulate source code that you're working on. So I'm going to now switch to the Fortran. So I might just keep going because in the interest of time. So in Fortran, the Fortran support is very similar to the C and C++ support. And essentially you can just, if you have a source file, Fortran source file, you can just open it and it will bring up the Fortran editor. By default, it's in a mode that is just a very basic editor. So it just really does syntax coloring, and it will recognize fixed and free format Fortran. If you want to activate the more sophisticated features of the Fortran editor, you have to tell the project that it's a Fortran project. And you do that by right-clicking on the project like we did before and say convert to Fortran. And then you have to go into the properties of the project and go to Fortran General and enable Fortran analysis and refactoring. And I'm just going to quickly do that. And essentially, so down the bottom you can see now it's running the Fortran indexer. And that's now indexing all the Fortran files. If I close this editor and reopen it again, you'll see now I've got folding enabled, and if I mouse over, if I find something that it knows about, if you mouse over a type, I can't find anything that's going to work. But it has the same sort of hover help that C and C++ would have if it knows the information about it. And there's also a very extensive refactoring framework for Fortran, so you can. It's much actually more extensive than the C one. So there are many refactorings available for Fortran. Okay, you can read through this documentation here to see what's available. So in terms of the real life example scenarios, I'll quickly go through some of these. We already covered the local development aspect. That's essentially just using a local version of a local repository. There are two scenarios for developing remotely if you're on a high-performance computing system. One is using Git and one is using remote synchronized projects. So in scientific computing, normally the application code is compiled and run on a remote system. So we need to be able to cater for that situation. And also, usually you interact with these machines via a batch scheduler or something. So we need to be able to deal with that. The first scenario is really the simplest way. Essentially, we're going to use the exact same setup that we used previously. So we clone a version of the Git repo that has our source code in it on our local machine, and we set up Eclipse exactly the way we just did. And then on the remote system, we're going to clone the same repository. So we now have two clones, one on the local machine, one on the remote machine. And so we now use the GitHub repository as our means of transferring changes from your local machine to the remote machine. So if you edit the code locally, you then push those changes to the central repository through a commit and then push, and that can take advantage of code reviews and Gerrit and things like that if you want to do that. And then on the remote machine, you pull the changes onto the target machine, manually run the build, and then manually submit it to the job scheduler. So it would look something like this. So we have a terminal session, so using whatever our terminal program is, connected to our remote machine for building and for job submission and for monitoring. And then Eclipse is working, interacting with the workstation repository. And when we make a change, we push that to the master repository, and then we manually pull it onto the target machine and rebuild. So that's a perfectly valid and effective development environment for using Eclipse for mainly doing your editing. If you want to use Eclipse to do essentially all of this, then there's another mechanism called synchronized projects. And in order to use this, you need the parallel application development package that I mentioned previously. So the vanilla C and C++ development tools don't have this in it. And essentially, Eclipse will manage the synchronization of two copies of the source code. And the answer is, a question just popped up then, which is quite cool, that said, does it know about fobs? And the answer is yes, it does. You can use the RSA tokens, and I use that regularly. It works fine. It's just that any time that you would need to use a RSA password, then or a fob or whatever, then you'll need to use it in Eclipse as well. So you may end up having to type the password on multiple occasions. But anyway, so this synchronized projects manages the 2 copies automatically for you. It can also be combined with Git if you want as well. So you can use both Git and synchronized projects. And so essentially it looks like this. So we have a Git repository somewhere in the cloud that's maybe the master repository, and you can clone that either to your workstation or to the target system. You can start either with a local or a remote copy, and then you set it up as a synchronized project. And anytime you make a change in Eclipse, Eclipse will automatically migrate the changes to the remote system. And if you want those changes to be committed to Git, then you would either need to do them on the Eclipse end through the Git integration, or you do it on the target system end through the command line. And then all the interaction with the target system can be through Eclipse. And so I'm actually not, I don't have time to show you that, unfortunately. Eclipse will, once you set up a synchronized projects, you can automatically build. So Eclipse will run a make command on the target system for you automatically across an SSH connection. You can do job submission. So this is a view of the job submission configuration type, and there's support for many job schedulers. So Talk and Slurm and everything are already supported. You can do system and job monitoring. And so this is an example of monitoring what's going on Titan. And you can see the activity on the nodes. You can see the batch queues, all from within the Eclipse environment. There's a remote console as well. It's integrated into Eclipse. So you can, from within the Eclipse IDE, you can open a console, and it's like having a terminal, essentially. So you don't need to run a separate terminal program. This would be useful for Windows because you don't need to install PuTTY or whatever. You can just do it directly from within Eclipse. And then finally, there's support for environment modules. So many HPC systems use environment modules to choose different compilers and libraries and so forth. And there's integration at the project build time, and also when you're submitting jobs to the job scheduler. You can pick the modules that you want activated at that point. So that's quite powerful support for those environment modules. So in summary, and I'm sorry I had to go a little bit fast through that, the final parts, but maybe I can work on OSNI to schedule another one of these webinars in the future that I can go into a little bit more detail on some of these other features if people are interested. But Eclipse provides quite a variety of different features to support scientific software development. So C, C++, and Fortran are very well supported. There's local and remote project management. There's really good integration with Git. There's support for job submission and monitoring, and there's environment module support. So you can, as a developer, you can, and if you like IDEs or you'd like to use an IDE, you've got a lot of different ways that you can pick how you would like to integrate that into your development workflow. So you can just use it for editing, or you could use it for the full workflow. So with that, I'm going to finish. I will just point out very briefly that this slide deck, if you keep going through this slide deck, there are more slides. There's an additional section that includes more information about different topics that I've talked about today, if you're interested in finding out more about those. And also feel free to email me or the PTP, the Parallel Tools Platform mailing lists, if you want to get more information. So with that, I'll turn it back to you, OSNI.
Okay, Greg, thank you very much.